Welcome to Aviation 101 with Laura. So a few months ago, I did a video about engineered materials arresting systems, EMAS. If you haven't watched that, I will put a link in the video description, so check it out. But these systems prompted some more questions. My students had some questions, and then I actually got reached out to on TikTok by a guy who works for Runway Safe, which was the company I was talking about in the original video. So you should check it out. Like I said, it's in the video description link. But this is Taylor from Runway Safe, and he has agreed to join us and answer a few of the questions that I have and other people had about their systems. So would you introduce yourself there, Taylor?
Yeah, sure. Hi, Laura. Hi, everyone. My name is Taylor. I work for Runway Safe. I've been here just about 3 years now. Prior to that, I was a horizontal construction engineer with the U.S. military. So I have a little bit of background in construction. I also have 2 degrees in aviation. So that's kind of how I ended up finding this place.
Awesome. So what are your degrees in aviation?
So I have a bachelor's in aviation management, and then I got my master's from Everglades University in aerospace science.
Nice. Okay. Well, awesome. Thank you for joining us on the channel today so we can learn more about this system. So what my students actually asked, like, what is the smallest aircraft that the system has stopped? So tell us about that.
So the lightest aircraft that we designed for is 12,000 pounds. That's about as light as we say we can predictably stop in a safe environment. However, the lightest aircraft that we actually have stopped is a Cessna 402 Charlie. That was in Fort Lauderdale. I think it was in 2023, where he overran the runway, I believe, due to wet weather conditions. So we stopped him.
I looked at the FAA's map about where these saves have been. I saw a lot of them are in Florida, and in fact, my students cued in on that too, and they were saying, "How come there's so many in Florida?" But what you just said makes a lot of sense. Wet weather. Florida
Mm.
does have more thunderstorms and like heavy downpours than probably any other state in the United States statistically. Do you think
Mhm.
that's why there's so many saves in Florida?
It's hard to say. There's a lot of factors, I guess, that could go into it. We've seen a lot up north as well in the cold weather and ice and snow, but
Yeah.
I do think it's a lot of what we've seen are those private jet size aircraft that end up overrunning the airport,
Mm,
and typically due to adverse weather is usually the
okay.
cause.
Yeah. Yeah. So not as much people landing horribly long
Mhm.
or something like that. But yeah, possibly a longer landing combined with the conditions of the runway. Yeah, that makes sense.
Mhm.
So, do you guys have like a running total of how many lives you've saved or aircraft you've stopped?
Yeah, so we do, and actually the FAA also has a count on their website. So we've stopped in total 27 aircraft, with actually 3 overruns in the month of September in 2025. The biggest one being that Roanoke one that you spoke about. The total amount of lives is 494 over the
Wow.
course of EMAS's history. So the biggest one was in Burbank. There was a 737. I believe it was a Southwest flight that overshot, and that had 117 people on board.
Wow. Yeah. Yeah. Burbank would make sense because that's not a huge airport either.
Mhm.
So, yeah. Wow. That is a lot of people. So, almost 500 people. And that's worldwide, or is that just the US?
That's worldwide.
Okay.
Off the top of my head, I do not believe we've had any incidences outside of the U.S.
Okay.
so far.
Yeah.
Um, yeah.
Are most of the systems in the United States?
So Runway Safe actually has 2 different types of systems. We have our EMAS Max, which is everyone from the United States would be more familiar with. That's what you're going to see a lot more of. And our other system is called a Green EMAS. They perform exactly the same. That's just more of how they're constructed on site. The EMAS Max is prefabbed in a factory and into 4 foot by 4 foot blocks and set on site, whereas the Green EMAS is actually built on site with a silica foam, and it's more of an actual construction project. As the EMAS Max is more of just an installation.
Next question. If an airplane like the Skyhawk that I fly or something small if it goes into the EMAS, would it actually collapse or not? Is it too light?
So there's a couple factors there. Something like a Skyhawk or a Cessna 172, something that only weighs a couple thousand pounds, it may crack through the top section of the EMAS, but
Okay.
it's light, so it wouldn't necessarily absorb all the way through the material. What you might see is a bouncing effect as it enters and exits the system itself
Mm,
until it eventually stops. So it would help the lighter aircraft slow down, but I couldn't say for 100% right now that it would stop it within a
okay.
predictable track. If a Cessna, this has happened before, like a Cessna or smaller aircraft has taxied across it, and you'll damage the system. Like the blocks, for instance, they have a plastic cover on top to protect the core material, and you would
Right.
crack through that, resulting in damage, which we'd have to replace parts of it. Um, there's also a deflector shield in the front that deflects the jet blast up and over the bed, so that would flatten or crush if you were to drive over it. We've
Okay.
seen a lot of instances with cars or trucks, especially ARF trucks, firefighting trucks, driving onto the EMAS, and they do cause damage.
Okay. So heavy vehicle like snowplow, even car, because yeah, car is
Mhm.
heavier. Car is heavier than my a Skyhawk,
Yeah.
or a snowplow. Okay, so that would cause damage, but it's not
Mhm.
gonna like grind to a screeching halt just because some ARF vehicle drove across it.
Correct. Yeah, it wouldn't grind to a halt. They'd probably be able to drive through it. It would definitely slow them down, based off the friction that it causes, but they would more than likely. We've had instances where people have driven all the way across the EMOS and out the other side.
Okay.
Um,
Yeah.
so it would definitely cause damage, but it wouldn't necessarily just like stop it dead in its tracks.
Okay. All right. I know you said something when we were emailing back and forth setting this up about having to be involved with putting the system back together at Roanoke, which totally
Mhm.
makes sense. So, can you share more detail on, say, for example, like the cost of replacing part of it? And then my students also had wanted to know if you can share, like, what does a system like this cost?
Yeah, so the cost it varies. They're not cheap by any stretch of the imagination, but it does vary because each of these systems are designed specifically for that airport. So Telluride, for example, has one on each end of its runway, and those systems are different than the ones you'd see at Teterboro or at JFK. Um, the systems are custom built for the fleet mix that the airports have currently, and then the fleet mix that they predict for the next 20 years.
Hmm.
So if they're only landing 747s in there right now, and then maybe they want to bring in MD-11s because their cargo is going up, we have to build a system that can support the future of their airport too. It's not just current. Um, but it really does vary on what the airport needs right now and in the future, and that the size and strength of the system changes the price back and forth. Um, but they certainly aren't cheap.
Yeah. Okay. And when you go in there to replace it, Um, then I guess you just send the airport a bill for like as many pieces that you bring in from your factory.
So a lot for the EMAS MOX side, since that is 100% produced in the United States,
Hmm.
most airports actually get AIP funding for those. So
Okay,
it ends
so
up coming
FAA
through the
funding from,
FAA.
yeah, okay.
Yep. So a lot of it comes through the FAA, especially with the bigger airports. It's a lot easier for them to get that funding. Sometimes when we're working with these smaller, more local airports, they do struggle with that, and we'll work with them to create a payment plan or however we can work so they can get their system in and be safe. Um, the green EMAS is produced currently is not produced in the United States, so that's a little bit more tricky for AIP. But
Hmm.
we are working on a solution to incorporate that more. Right now, we only have four green EMAS systems in the country, and those all four of those systems are at Midway in Chicago.
Okay, okay. Yeah, I noticed that they have a lot of them, but I
Yeah.
guess I imagine this is primarily driven by either terrain near the end of the runway and or the built environment. Like you've got roads and buildings and reasons why the runway cannot be longer frequently.
Yeah. So if you look at the map on the FAA website, you'll notice there's a large majority of them up in the Northeast,
Hmm.
and a lot of those airports are quite old, and they were bought and built around those hubs, around the cities, which then expanded around the airports, constricting their ability to grow. Um, Out west, you see a lot of these airports are a lot newer, and they were able to buy up more of the land and had more room to grow. So once they get constricted by the cities and houses and everything else, they really EMAS is kind of like their only option if they want to increase the aircraft size
Yes, I see. Okay.
or buying hundreds and hundreds and hundreds of houses.
Well, yes, but then you get very unpopular with the neighbors, and people don't like getting displaced out of house and neighborhood, and yeah, yeah. So, how long does one of these installations? You said 20 years. Is that about approximate how long before it has to be like replaced fully, or is there's a maintenance cycle on these systems?
Yes, our systems all have a 20-year lifespan. That's from date of installation. Once that's complete, we run basically a clock for 20 years. We offer yearly inspections from ourselves. So myself or one of my colleagues will go out there once a year, do a couple hour walkover of it, check it out, write any deficiencies down, offer to send them supplies to do if they want to do the maintenance themselves. It's very easy maintenance to do. Um, so they can do that, or we can send somebody out, a contractor or ourselves, to come out and do the work. But what we see over the years is the UV and the weather starts to eat away and degrade some of the parts a little bit, which then we offer uh, kind of like a patchwork, I guess, more heavy duty maintenance in order to make sure that whole system lasts that full 20 years. Because we don't want to, be replacing a system in year 12 when you could still get 8 years out of it. But if we can
Mhm.
do a little bit of work now to get you those extra 8 years, it's a lot easier for both parties.
Is this like trending upward? Worldwide? Are you seeing more interest outside the US, or, is it like you feel like you've got most of the airports in the US that needed it, or, is there like growth in your area here?
There's still definitely a lot of growth out there. We definitely we are seeing an uptick worldwide. We actually just did an installation in Queenstown, New Zealand,
Hmm.
last February, and then currently right now we're installing in Wellington, New Zealand. Um, on top of that, we have installs coming up in Brazil. There's some Asian countries that we are hoping to work with. There's currently a lot of interest in EMAS and protecting these aircraft out there right now, especially I guess it was almost this time last year that Korean airplane overshot the runway and hit that concrete wall.
Hmm.
Um, so that was a big topic around here, and we ended up fielding some phone calls and talking to people out there about that. So there's definitely a lot of interest in it right now, which is good for everybody, honestly.
When I've seen these, it seems that the aircraft is typically mostly undamaged.
Hmm. Yep. So there are some where there is some light damage to the aircraft, but for the
Yeah.
majority of them, those aircraft are able to be pulled out of the system same day, and then that airport can operate uh, basically as it was until we're able to get in there and replace it. I think Roanoke, they pulled that aircraft out the next morning, and then the airport was opened up fully the next day.
Yeah, which is awesome. I mean, and if the airplane had rolled off the end and gone down that embankment,
Mhm.
I mean, for one, people would have been injured. For two, the airplane definitely would have been maybe like written off. And three, the airport would have had a closed runway for a long time.
Mhm. Yeah. The only thing I'd say to pilots out there is to look at your Jefferson charts. See if the airport you're flying into has an EMAS at the end of it, in case hopefully you don't ever need it, but in case you do need it, you know that it's there. We do see a lot of these about a lot of these pilots when they're coming in and they're going to overshoot the end of the runway, they'll see something at the end of the runway, which would be our EMAS, and they'll actually try to avoid it instead of hitting it.
Oh, okay.
So that's something we see relatively frequently, that an aircraft will enter the EMAS, but they'll turn because they were trying to avoid it because they
Hmm.
don't know either what it was or how it functions.
Okay.
And
And
that's
it's
something we're
better to
trying to
like go
rectify.
straight into it.
Yeah, you'll 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 stop if you're turning, you'll still stop, it'll still function the same, but the performance blocks are straight in the middle. There are side steps on the edges, which technically are not performance blocks, they're for egress off the system. However, you want the most amount of stopping room possible on all sides, so shoot for the middle of it.
Okay. So if you know you're rolling off the end, just go straight. Just
Yeah,
go straight and trust the system to do its job. Yeah.
yeah, yeah.
Yeah. That is really good advice. And I guess I forgot this question too. I keep saying one more question. Speed when you enter it, like how high is speed has this been tested at to stop aircraft? You have an
So
upper limit?
so we say 70 knots is our
Okay.
ideal speed for
Yeah.
entrance. I don't have an exact number of the fastest an aircraft's been into one. I'm sure there have been some that have been faster than that, but hopefully, if you're already attempting to stop, you should be within that 70 knot threshold.
Hmm. If you're that close to the end of the runway too. You
Hmm.
probably have been braking heavily
Hmm.
up to that point, hopefully. So yeah. Okay. Well, that is really good, and I will definitely be sharing that piece of advice too that you've given us to pilots. So, all right, thank you so much for being here, and make sure you guys put in the comments what you like, what else, what other interviews might I do, what else have you had experience with these systems, and yeah, thank you. Don't forget to like and subscribe. Have a great day from Laura at Aviation 101 with Laura.